Bismillahirrahmanirrahim. Exercise 3.4, question number 1, part 1. Integral of x sin x dx. We are going to evaluate this integral by integration by parts. The formula for integration by parts is integral of f of x g of x into dx. Considering fx as the first function and g of x as the second function, the formula for integration by parts takes the shape: first function constant, integral of second, minus integral, inside the bracket derivative of the first function, and then the same integral. This integral is repeated here. Then we close the bracket and we get a dx for this integral sign. The previous knowledge which we must have is d by dx of x equals to 1. We also must know that integral of sin x dx equals to minus cos x plus c, and we know that integral of cos x dx equals to sin x plus c. Let's start the solution. We name the given integral as I. Integral I is equal to integral of x sin x dx. We consider x as the first function and sin x as the second function because integration of both the functions is possible. So our choice depends upon the first function, as derivative of x is equal to 1 and it is of lower degree. So we take x as the first function. Now let's perform integration by parts. Integrate by parts, and we get integral I is equal to first function constant, integral of second, minus integral derivative of first function, that is d by dx of x into the same integral, integral sin x dx, and we close the bracket and we have a dx here. First function constant, integral of second, minus integral derivative of first function into the same integral. You can see the same integral. Then we close the bracket, and for this integral sign we put a dx here. Now let's write the results. X, integral of sin x dx, we have revised the result from here, and we get minus cos x, minus integral d by dx of x is 1, and integral of sin x dx is minus cos x, and then comes this dx. You must note that I have not introduced constants of integration, because when we perform integration by parts, we introduce constant only in the last performed integration. So these were not the last performed integrations. We have to do this integration further now. So we will introduce the constant of integration only when we will do the last integration. Let's open these brackets. Minus x cos x, bring this negative sign outside, minus minus becomes plus, and we have cos x dx. Now you can see we have to perform this integration, and after this there will be no more integrations in it. So this will be the last performed integration. So we will introduce constant of integration in it. Let's do it now. Minus x cos x, and what is integral of cos x dx? It is equal to sin x plus c, plus sin x plus c, and this is the answer. Integration has been completed. Now it's your choice. If you don't like to start your answer with the negative sign, you may rearrange it and you may write it as sin x minus x cos x plus c. It's up to you. It won't make any difference. And that completes the result.